At present we are discussing about the matrix chain multiplication. This chain matrix multiplication uses the dynamic programming. It's one of the design techniques. It solves the problem like divide and concurrent. It is depend on the problem which type of techniques we are using, divide and concurrent or dynamic problem. The matrix chain multiplication we are using the dynamic program. Suppose we have a sequence or chain A1, A2, An of n matrices to be multiplied. That means we multiplied the number of n matrices which are A1 to An. There are many possibilities ways for this n number of matrix multiplications. We explain it. To compute the number of scalar multiplication necessary. That means the different way we multiply the n number of matrix multiplication, but our target is minimum number of scalar multiplication finding. It's called the minimum multiplication cost. At first we multiply the two matrices. Then we explain the n number of matrix multiplication. We must know the algorithm of two matrix multiplication. Now we explain with example. Example, consider two matrices A and B. A matrix order is 2 cross 3 and B matrix order is 3 cross 3, and the resultant matrix becomes C 2 cross 3. That means the resultant matrix order is 2 into 2. Let's A be the matrix 1, 2, 4, 3, 9, 9 is the A matrix element whose order is 2 cross 3, and B matrix whose column is 2 and row is 3. And element are 0, 1, 1, 4, 5, 8. Now the procedure of matrix multiplication, the 4 fields are there because the new matrix order becomes 2 cross 2. How to multiply? At first we fill this position. At first this A matrix row and B matrix column at first multiply, then fill this first position field. Look this. We multiply 1 into 0, 2 into 1 and 4 into 5. The result is 22. We put the 22 here. Here we find the number of multiplication for this field 3. 1, 2 and 3. Next we multiply this position. For this field we multiply this row, huge this row and huge the row of A matrix and huge B matrix this column, and the result is 54. How? 3 into 0 plus 9 into 1 plus 5 into 9 into 5. 54. Here also we find the number of matrix multiplication 3 times. In this way, the total number of matrix multiplication, the resultant matrix is 22, 54, 41, 8. The total number of matrix multiplication is 12. That means for 22, 3 multiplication, for 54, 3 multiplication, 3, 3, 6 multiplication, and another for 41, 3 multiplication. That means 9 multiplication, and this 3 multiplication. That means total number of 12 multiplication. The total number multiplication is 12. We find out the matrix cost 12. That means the A matrix 2 into 3 and B matrix 3 into 2. That is, the matrix cost is 3 in 2 into 3 into 2, that is 12. The matrix multiplication cost depend on the matrix order. It is not depend on the matrix element. Always matrix cost depend on the matrix order. Now, example, consider the 3 matrix multiplication. A matrix which order is 10 into 100, B matrix 100 into 5, and C matrix 5 into 50. The two possibilities where arise. One is A at first multiply A into B, then C. The A into B matrix cost is 5000. Then the result is this, and also this D multiply and this. Then the total number of cost between after multiplication of D and C is 2500. But total multiplication for this result is 7500. But B, again the another method is at first we multiply B and C, then multiply A. The BC multiplication cost is 25,000 and AE multiplication cost is 50,000, and total multiplication cost is 75,000. The result is same. The element matrix multiplication result is same first, but the cost is different. That means the number of multiplication in this way 7500, but when we multiply this way, the total number of multiplication 75,000. That means our better case is if you use this techniques. That means this way. So matrix cell multiplication also, if we use the n number of multiplication, then our target is find out the minimum cost. There are n number of matrix I to n, and the dimension are pi represented by pi minus 1 to pi. Our target is to find out the matrix minimum cost. We matrix divided into two part. At first 1 to k and k plus to n. That means ai total number of matrix ai to j. That means ai to, at first we multiply the ai to ak, then we multiply ak plus 1 to aj. That means the cost of computing aij equals to cost of computing aik plus cost of computing aik plus 1 minus j plus cost of multiplying aik plus ak plus 1 to j. The cost of multiplying aik and ak plus 1 to is pi minus 1 pk plus pi minus 1 pk pj. That means the cost is mij, it's represented by mik I to k plus mk plus 1 to j plus this one, and k lies between I less than equals to k to j. That means k lies between I to j. This is the final result if I and j is equal. That means it's same matrix we cannot multiply. We only the difference matrix multiply when I equals j0, and otherwise when I less than j the result is happen. This is the general way of matrix multiplication. It is the very important algorithm in the dynamic programming approach.